We're beginning our last chapter for this course, which has to do with an introduction to some concepts in statistics. This very first lesson, 12.2, with measures of central tendency, is likely to be something that you're very familiar with. So today's lesson won't be too hard. So what are measures of central tendency? Well, our very first one is called the mean. And a lot of times this is what those of us that are not truly statisticians actually just talk about as being an average. It is that mathematical or arithmetic average where you simply add up all of your values and divide by how many values you had. But the statistical term for this is the mean. And this little symbol here means summation. So it's the summation of all the x's. So add all the values and divide by the number of items you had. So what you have typically called the average, this chapter will be referring to as the mean. I will try to call it the mean, but I'm actually not a statistician either, so you may very well hear me slip up and say average. If we're going to find the mean of these values, we simply want to add them all and then divide by how many there are. So that's going to be the sum of the x values. And I know I said my board wasn't working, it doesn't matter, but I'm trying to do this with a mouse. The sum of the x's, and then we've got to divide it by n. So these are the x values. So you want to add all of these up. So the sum of the x's then is what we're going to get when we add all of those values. So let's pull up that calculator. So 74328 Hit enter. The sum of those values is 33. So then I need to do 33 divided by how many values there are. And of course, when you're doing this on your online homework, just read the instructions real closely, because a lot of times it may be a whole number here, but a lot of times it's going to be a decimal. And so read what you need to round to. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 values, so I'm going to divide by 8. I can just hit divide and it'll automatically do the answer divided by. So I want to do that answer divided by 8, and I get 4.125, or approximately 4.1 if I took it to the nearest tenth. Now the symbol for the mean, which is going to slow up on another slide, is x bar. So if you see an x bar, it's like taking your x's and actually doing this math with them. So mean is one of our very, very common measures of central tendency, where we just add the values and divide by how many there are. We can find the mean for a frequency distribution, where a frequency distribution actually has kind of shortcutted our list of data, and instead of listing every single one of them, it tells us how many times a particular one occurred. So like on this one, I had this 3 that showed up twice. So it would just have a 3 and then would have a 2 out beside it, so you know how many times it shows up. And so when we're going to find the mean, and you do see this x bar here, it was probably on that previous slide also. When we're going to find the mean, you don't just add the x's. First of all, you have to take the value and then multiply it times the frequency of it. So it would be like not just adding a 3, but adding a 3 times the 2 times it appeared. So we will multiply before we add and then divide, and that gives us a frequency distribution mean. So this is what that could look like. So what we want to do each time then is we want to first of all take this particular thing and multiply straight across. So as I multiply across, what we're going to have then is 1 times 1 is 1. 2 times 3 is 6. 3 times 4 is 12. 4 times 4 is 16. 5 times 6 is 30. And this is 6 times 5, so another 30. 7 times 3 is 21. And 8 times 2 is 16. So what this column represents is x times f. Now what we need to do is actually add these values. So I'll pull back up that calculator and just punch those in so that we can add those values. I get 132. So that's right here, 132. That is the sum of my x times f. So if we go back to that previous thing, that means I've just finished this top part of the formula. So now I need to divide by how many values we had. N is the total. Notice this is the total frequency of the distribution. Because when we look at this distribution, this right here, like this 4, it means I had 4 of the 3s. I'm not seeing the entire list. So if I want to find the total frequency, that's actually adding this column. And we might can just do this one aloud. So 1 of 3 is 4, and another 4 is 8, another 4 is 12, plus 6 is 18, plus 5 is 23, and then plus another 5 is going to be 28. I certainly could have used the calculator for that, but just adding those up, then we have 28 values. So then, to actually get the mean of the frequency distribution, we take our first sum there divided by the number of values that were in our data, even though we don't have them all listed here. So we've got to do 132 divided by 28. And I'm going to put 4.7. Again, read your instructions very closely about how to round, but typically they round it to one more decimal place than the original values had. So since these were all whole numbers, we'll go one place after the decimal. If we had a whole list of numbers that included one decimal place, we'd go 2, and so on. 4.7. So that's the mean from a frequency distribution. So the difference is we had to multiply first, and then in order to find out how many we had, we actually had to do the sum of the frequencies. So mean, whether or not it's from a distinct listing of data values or it's from a frequency distribution, still actually is calculated essentially the same way, and it's what you've commonly called an average. Now, mode is the data that occurs most often. So generally, we're just looking for what appears most often. However, it could be that there is no data value that occurs most often. So it's possible that there is no mode. It's not possible that you won't have an average from a data listing. So you would definitely be able to calculate the mean. You could find the range. You can find other things. But the mode may not exist because maybe all of the pieces of data occur exactly the same number of times. However, it also is possible that you could have a couple of modes because maybe you have 2 things that appear more often than anything else. But for mode, we're looking for most often. Here, these blue lines are to separate different problems. So we have 3 sets. So if we want to calculate the mode, it's not so much a calculation. We really do this by inspection. What values appear the most? Well, I can see here that I have a 3 that appears twice, and nothing else appears twice. So for this very first row, the mode is 3. Now looking at our next one, these zeros are jumping out at me. So I have 0 and 0, and then a 0 over here. 0 appears 3 times, and none of the other values appear 3 times. So 0 is the mode. Let me see, I have a 95 that I'm seeing twice. And nothing else even appears twice. So in this row, 95 is the mode. Oh, that's a bad looking 9, but again, I'm using a mouse. It's kind of crazy. The mode is not difficult to find at all. Just keep in mind there could be no mode. If they all appear exactly once, there's no mode. If I had maybe another 97 here, then I would have a 95 and a 97 that appeared more than the other ones, and I could have 2 modes. Okay? So now we've done mean and mode. Our next one is median. The median is really the middle value, but it's not your middle from your original list. You want to arrange all of the data items in order from least to greatest. Truth is, it could be from greatest to least also. And then we're going to find the middle. However, there's 2 different steps here, even though I only mentioned one, find the middle. And that's because if you have an odd number of items, the median actually will be one of those numbers. But if you had an even number of values, like if you only had 4 values, what's in the middle of 4 values? Well, it falls right in between 2 of them. And so you actually have to add those 2 middle ones and divide by 2. Now we'll do that in just a minute. But the other thing is, how far down the list does this end up being if you have them arranged from smallest to greatest? So the value in the position, and sometimes this is a faster way to find it, particularly on a frequency distribution. If we had 27 items, then I would do 27 plus 1, which would be 28. 28 divided by 2 is 14, so I know the 14th number on my list when they're in order would be the median. On the other hand, if you had like 10 items, 10 plus 1 is 11. 11 divided by 2 is 5.5, which tells me it's the median is the mean of the 5th and 6th, because 5.5 falls between 5 and 6. So I would have to find that. So anyway, we can use that also. So we've got this on a couple of different things. Find the median. Again, the blue line is separating two problems here. If we want to know the median, then we've got to line these things up in order. And on this listing, they are not lined up in order, so we're just going to have to rearrange it. So the middle then is going to be the middle value, and you could just kind of say, okay, I'm taking one off the top and the bottom, one off the top and the bottom, and just kind of repeat this process. And what's going to happen is we see here I have two values that are there in the middle. So this is that indication that I need to find the mean of those two values. So we're going to take 3 plus 4. And sometimes, you know, like this one you might can just do in your head. Sometimes you're going to need a calculator. 3 plus 4 is 7, and 7 divided by 2 is 3.5. What you see is that the median is not even one of our original numbers. The mode has to be one of the original numbers, but might not exist. It doesn't have to have a mode. But the median, it's going to have a median, but it might not be one of the original numbers. Okay? The mean might not be an original number either. So that is finding the median from just a listing. You want to get them in order and work your way to the center. If we have a frequency distribution, these are in order on a frequency distribution. So this is where it's most helpful for us to find out where the position is. And so to find the position, what you're going to want to do is first of all find out how many values you're dealing with. And I think this might be the same one I listed before. I'm going to go back and check because we already did that. When we added those up, 1, 3, 4, 4, 6, 5, 3, 2, there were 28 values. 1, 3, 4, 4, 6, 5, 3, 2. Okay, so I know that there are 28 values here. And that means if I want to find the middle value based on that previous thing, the position of the median would be 28 plus 1. You're always going to add 1 to it, and then divided by 2. So that ends up being 29 divided by 2, which is 14.5, which tells me it's between the 14th. I need to actually find the mean of the 14th and the 15th values. So what you want to do then is start counting your values from the top. So here I have 1 value plus 3 more. Now I've covered 4 values, plus another 4 is 8 values, plus another 4 is 12 values, and then plus another 6 would bring me up to 16 values. So right here, both the 14th and the 15th values are 5. So even though it would tell me that I needed to do the average, since they're both 5, I know that this is a 5 for my overall answer. And again, that had to do with just adding up and figuring out how many values I covered, and I was looking for the 14th and 15th. If they had not been the same, if it had been on 2 different rows, I would have added those values and divided by 2. But again, this is the first value. 3 more brings me up to the 4th. 4 more brings me to the 8th. 4 more brought me to the 12th. So this represents the 13th, 14th, 15th, 16th, 17th, and 18th values. That is just, that entire listing would be 5. So I know when I find the mean of 2 5s, I'm going to get a 5. So we've looked at mean, mode, and median, and don't forget we did mean from both the frequency distribution like this and a listing and data values. So the next concept is mid-range. Now, don't get mid-range confused with the range. When we did range, we subtracted the highest minus the lowest, but to get the mid-range, we add and divide by 2. And when I say we add, we're adding just the lowest value plus the highest value, and we divide by 2. So mid-range is different than range, and it's different than median. But we're going to take the lowest and highest data values, add, divide by 2. If we have this listing, and you want to find the mid-range, the lowest value anywhere on this list is 40. The highest value on this list is 100. We're going to have 140 divided by 2, which means the mid-range is 70. Here's kind of where this works. If we were finding a range, we would have done 100 minus 40, and we would get a range of 60. Now, half of that range, like the middle of the range, is 30 points, but it's not 30, it's 30 points into it after you start. So if you found half of the range and you added it to your low value, you'd be back here, because that's saying if we went, just concept-wise, if we went from 40 all the way to 100, then we would have covered 60 values. But half of that, halfway in between those, is that mid-range, and that's where our 70 is. So that's 30 values from each end. The mid-range is also very easy to calculate. This is what we've looked at in this section: mean, median, mode, and mid-range. Mean, median, mode, and mid-range are all measures of central tendency. So if you have these values for 6 test grades and you want to find the mean, median, mode, and mid-range, let's get our calculator back up. The mean occurs when you add them all and divide by how many there are. So I know there are 6 test grades, so let's add them. Had a rough start to the testing, then improved, got on solid footing, really getting the hang of it. And of course, by the time you get to the end of the class, you've just mastered it. So I'm going to add all of those up and then divide by the 6 grades that we've entered. So your mean test score would be 76.7. Your median test score is the one in the middle. So for us to do that, we want to take the middle of 6 values, which really there's no just single value in the middle of 6. It's going to be the mean of the 3rd and 4th values. So these are handily lined up from least to greatest. So when I look at the 3rd and 4th values, they're right here. We could take off 2 from each end. These are the 2 in the middle. So I want to add those 2 and divide by 2 to get the median. So the median was 80.5. Now the mode is the score that appears most often. A mode does not have to exist. If you had made a different score every single time, there would be no mode. But here I see that an 86 is twice. So the mode is an 86. Now if we want to find the mid-range, we add the low value plus the high value and divide by 2. 52 plus 92 and then divide by 2. And that gives us 72. Now all of these are a way of talking about what the general performance of something is. That's why it's called central tendency. But just think about that meaning. If you were a young student, maybe a teenager, or you have a teenager, and you're asking, somebody asks, how are all the tests going in your class? You could say, well, you know, my mean or my average score is a 76. So that sounds like you're hitting just above a mid-C. Or you could say, well, my median score is an 80.5, which actually just tells them there's some below and some above that, the equal numbers, you know, but that sounds like you've got a a solid, but it's a B, B minus. Or you could say, well, I've made an 86 more than I've made anything else. So that's sounding really good, okay? Or you could say, well, if a 72 would probably hit right in the middle of all of my scores. So you can see you can really adjust how that sounds by what measure of central tendency you report. So the most interesting thing to statisticians is to look at all of these values, because the closer they are together, then the more consistent that performance is. Just imagine if you had made 86s all the way across here, then the mean would be an 86, the median would be an 86. You could say there's no mode because nothing else occurred, and the mid-range would be an 86. Okay, so they would all start to be the same, and they get closer and closer together the more consistent the performance is. And so that's what statisticians are generally looking at. Again, I'm sorry for the difficulty I had in writing, but you guys have been really patient with me, I think, so far. I think this will take care of your homework for 12.2. And hang in there, we're almost done with the class. Send me questions you have by Ask the Instructor. Thanks.